Hello, welcome to our channel. Do you know that high-speed systems are becoming increasingly common, and large volumes of data are now exchanged over high-bandwidth Internet link? During high-speed communication between Internet devices, it is often necessary to capture and analyze traffic to understand behavior, debug issues, or validate system performance. At 100G Internet rate, logging this data becomes complex, time-consuming, and expensive to validate on the real hardware. At this speed, software-based logger cannot keep up, limited by CPU, operating system, and unpredictable latency. That is why we introduced DG FPGA-based 100G Internet Data Logger, a ready-to-use solution that cuts development time and record data at full 100G speed. It's easy to integrate, easy to customize, and already proven on the real hardware. Let's see how it works. To log data from 100G Internet interface, the system must store Internet data at full line rate, without relying on CPU or operating system. DG solution use our NVMe-IP, allowing direct access to Gen5 NVMe SSD. With Gen5 NVMe SSDs, sustained throughput of around 12 GB per second is achievable, sufficient for continuous 100G Internet logging. When combined with exFAT2-IP, the system records data in exFAT file system, again without any OS or CPU involvement. Captured data is stored in PCAP format, enabling immediate post-analysis with standard tools, such as Wireshark. Because this is a FPGA-based system, the data logger is fully configurable. There are three main sections that can be adjusted to match different system requirements: Ethernet speed, which defines the network interface bandwidth; DDR memory, which determines the data buffering capacity; and NVMe storage, which defines the capture capacity and overall system performance. On a G-Link 7 IC, the data logger can be configured for 100G, 200G, or 400G Ethernet. This is enabled by the built-in F-Type Ethernet hard IP, which supports multiple Ethernet speeds using the same hardware platform. For data buffering of the system, it supports multiple DDR4 memory resources, including 2 DDR4 DIMM slots of external memory, as well as 2 onboard DDR4 memory blanks for reliable, high-speed buffering. With the built-in R-Type PCIe hard IP, storage device can be connected to either the PCIe Edge connector or MCIO connector, supporting configuration of up to 8 NVMe SSDs. As the number of SSD increases, storage throughput increases as well. This scalable storage architecture allows the data logger to support higher Ethernet speed and longer capture duration, without requiring system redesign. Although the data logger is highly configurable and scalable, we start with the base system configuration for clarity and ease of use. The base system operates at 100G Ethernet and uses 1 DDR memory channel for buffering, along with 1 NVMe SSD Gen5 for storage. User can send command and configure internal parameters through the Neon 5 terminal, including up to 8 configurable packet filter rules. For convenience, we also provide a GUI application that allows users to select and generate filter rules, which can be applied through terminal. First, we set up the base system. We use 2 PC connect to the FPGA board through 100G Ethernet. Next, we install the DDR4 DIMM to provide the required buffering memory. Finally, we connect a NVMe SSD Gen5 to the PCIe interface using our AB20 adapter board. If you want to replicate this setup, we also provide a step-by-step setup guide, so users can follow the process easily. At the beginning of demo, we need to configure the packet filter. Filter parameters are set using the GUI application provided with the demo. Through this interface, user can define protocol, MAC address, IP address, and the port-based rule, selecting exactly which traffic should be recorded. Once the filter is configured, recording is straightforward. The user simply selects the record option, and the system immediately begins capturing the filter Ethernet data to the SSD. After recording is complete, the NVMe SSD can be connected directly to a PC. The drive is mounted as a standard exFAT2 system, allowing captured data to be accessed like any normal storage device. The record data is saved as PCAPNG files, which can be opened immediately using Wireshark. This enables instant inspection and analysis of captured packets without any data conversion or post-processing. That concludes our overview of the FPGA-based 100G Ethernet data logging solution, designed for sustained high-speed capture, scalability, and real-world deployment. For more information, technical document, and evaluation material, please visit our website. Thank you for watching.